In this video, I will be demonstrating how to create programs using conditional statements. Normally, statements in a computer program executes one line after the other. For this example, I will be accepting first number and another number. The compiler will execute this program line per line, starting from line 1, then going to line 3, line 5, line 7, and so on. You cannot skip one line in this kind of program. This is what we call sequential execution. But there are various C statements that will enable you to specify which statement will be executed next. This is what we call the transfer of control or selection structure. In order to do this, we make use of conditional statements. Conditional statements check an expression whether it will execute a statement or a block of statements depending on the result of the condition. The condition uses relational, logical, and equality operations, which determines whether the expression is true or false. The C language provides the following conditional statements. We have the if statement, the if-else statement, the if-else-if statement, and the switch statement. Conditional statements are used to choose among alternative courses of action. In the flowchart, we make use of the decision symbol. This symbol contains an expression such as a condition that can either be true or false. Therefore, there will be two flow lines emerging from it. One indicates the direction to take when the expression in the symbol is true, while the other one is the direction to take when the expression is false. Decisions can be based on conditions containing relational or equality operators. The general form of the if statement is if, then your expression, enclosed in the open and close parentheses, followed by the statement that it will execute if the condition is true. We make sure that we follow the correct general form or the correct syntax to avoid errors. Let us make use of this program that will accept two numbers and store it in N1 and N2 variables, assuming that you will enter numbers and compare them whether which one is greater or lesser than the other, or if they are equal. So we could say that the first number is greater than the second number. We could also have a display wherein the second number is greater than the first number, or they can be equal. Both numbers are equal. If we will run this program, if we will execute it, all the three possible outputs will be displayed. We have the first number is greater than the second number is greater than the first number, and both numbers are equal, which is not correct. The error is a runtime error wherein it does not give the correct output. Therefore, we will be using conditional statements. We will write the expression or our condition. Since the first number is stored in N1 and the second number is stored in N2, we will use those variable names. So we have if N1 is greater than N2, so you see we will be using the relational operators. If N1 is greater than N2, therefore, the first number is greater than the second number. If N2 is greater than N1, the second number is greater than the first. While we have the equality, we have if N1 is equal to N2, both numbers are equal. In here, we could also say N1 is less than N2. That is also a correct expression that will yield the result the second number is greater than the first. Let us try to execute. We have 80 and 74. Therefore, the first number is greater than the second. Then let's have another 50. This time, the second number is greater than the first. We have 50 and 50. Both numbers are equal. In this example, we have three ifs. We have 1, 2, 3 ifs. Therefore, we also have three conditions. And for every condition, there is one possible output. Meaning, if this is false, it will not execute any. Now, I will try to remove this last 4 lines. And I want to break this one line into 2 lines. We have printf, the first number is greater than, then I will put in the second line this part. Now, if the case is we have more than one line that needs to be executed within the condition, we have to make use of the open and close curly braces to indicate that there will be blocks of statements and not just a single one. Let us have another statement. Thank you for using this program, meaning this is independent of our condition. If the first number is really greater than the second number, the first number is greater than the second, then thank you for using. But what if we have 10 and then 12? The compiler will not execute the one inside the block, but it will execute the one after the block, which is thank you for using this program. If you will notice the if statement, if the condition is true, it will execute a statement or a block of statement. But if the condition is false, it will not execute any statement. That is the limitation of the if statement. So now we proceed with the second conditional statement, which is the if-else. You still have one condition, but you have 2 possible outputs. This is by using the else keyword, wherein if the condition is true, it executes this part, and if it is false, it will execute the one in the else part. So that is the difference of the if and the if-else. The next conditional statement is the if, else if. This time, you will have more than one condition and more than one possible output. Instead of else, the condition is false, we have else if n1 is less than n2. Therefore, the second number is greater than the first number. And the ending is the else part, wherein if the other conditions are false, it will execute the else part. The 2 numbers are equal. So we have 1, 2, and the second number is greater than the first. Thank you for using this program. Let's make use of the new line. And 2 and 1. The first number is greater than the second number. Thank you for using. Then we have 3 and 3. The 2 numbers are equal. This is also true with the negative values. So the second number is greater than the first. So let's have another example. I'll save this and then open a new one. Let's save it as grade.c. We have the void main. Assuming that the grade is float, because a grade can contain decimal places. Let us display a message to let the user know what to type in. %f, since it is a float. Then we have the ampersand to indicate the address of the variable grade. We will have either passed or failed. So this is a sequential kind of statement. If, for example, our grade is 75, we have passed and failed, which is incorrect. Since this is a sequential kind of statement, but we have to choose between these 2 statements, we make use of conditional statement. We have the if. What is our condition? If grade is greater than or equal to 75, therefore passed. Assuming that we don't have this yet, 80 is passed. but 74 is no output. We'll use the second kind of conditional statement, if else. So we have 73 failed, 90 passed. But what if the user will enter a grade 200? Oops, there's no grade such as this. You cannot say passed. This time, we have to set boundaries. Let's take, for example, if the grade is 75 to 100, that is passed. The lowest grade is 65 to 74, that is failed. Meaning, greater than 100 and less than 65, meaning 64. Greater than 100 is 101. Less than 65 is 64. This is an invalid grade. If we have a range for the past output, we will change the condition. We will be adding grade is less than or equal to 100. So we have if grade is greater than 75, if grade is less than 100, we make use of the AND operator. Meaning this should be true and this should be true for this whole condition to be true. Because the AND operator will yield a true value if both conditions are true. If one of them is false, therefore it is false. So we have to use the AND. While else if, so this is the third conditional statement. We have the if else if. We have more than one condition. The grade is, what is that again? 65 to 74. Else if grade is greater than 65 and grade is less than 75. If it is greater than 65, which is 66, and less than 75, which is up to 74, it is failed. Else, if condition 1 is not true, if condition 2 is not true, you will go and execute the else part, which is invalid entry or invalid grade. So let's try a passing grade. We have 95 passed, 71 failed, 200 invalid grade, 63 invalid grade. Let's try to change the output. We could say congratulations, you passed. I'm sorry, you failed. Then we have invalid. Oops, that is an invalid grade. We also have what we call the nested if statement, meaning there is an if statement inside an if statement. For example, this if part, we will add another if inside it. We add the curly braces. Then let's say that if it is a passing grade, yes, it is 75 to 100. But if it is of line 7, we could indicate there. So we could say, congratulations, you passed. Then if the grade is less than 80, we say that is a line of 7. 98, congratulations, you passed. That's it. But if it is of a line 7 grade, but it is a passing grade, 78, congratulations, you passed. That is a line of 7 though. Then what if we would like to comment something here? So we have 89. So congratulations, you passed. Great, that is not a line of 7. So this is an example of a nested if. There is an if statement inside the if. The next one is the switch statement. Let us create a new program. Save this file as the switch.c. For the switch statement, the general form is the keyword switch, and then inside this switch is your variable, and then you will have several cases. So let's have a variable declaration first. We have int n. Then we ask the user to enter a number. Then we will accept the number, store it to variable n, switch keyword, then inside the open and close parenthesis would be your variable. Then you have open and close curly braces for the entire set of codes for the switch. We have several cases. We make use of the keyword case, then 1, meaning 1 will be the possible value of the variable n. We could say 1, like we are converting a digit into its word equivalent. Then after that, we will have a break statement. That means it is up to there only. Then we have another, if it is 2, you say 2. Then break. If the user entered 3 and stored it to variable n, you will have 3. Then of course, break. The else equivalent in the switch statement is default, meaning if n is equal to 1, you will do this. If the variable n is equal to 2, you will do this, and so on. But if n is not equal to 1, 2, or 3, in any of the possible cases, it will go to default. That is not included in the program. If I entered 1, 1. I entered 3, I'll enter 0. That is not included in the program. What if we did not include the break part under 1? Will it be an error? No, it will still run. There is no compile time error, but there will be a runtime error. You see, you entered 1, it will print 1 and the 2. After this, it executed this again. And what if we remove this also? What will happen if we entered 1? We will have 1, 2, and 3. Because we entered 1, it will print 1, it will print 2, and it will print 3. But what if I typed in 2? There, 2, 3. So that is the importance of including the break in each of your cases. Can you have more than one line? Yes. Uno. No need to put open and close curly braces even if you have more than one line because it's already part of the case up to break. So 1, 1 or uno, 3, 3, 3 or tres, new line. So that is the use of the switch statement. I hope you understood the different kinds of conditional statements and make use of them depending on the program that you will be creating. Let's have a recap. We have the if. There's only one condition, one output. The if-else, one condition, two outputs. We have the if-else-if statement, two or more conditions, two or more outputs. And we also have what we call the nested if, wherein there is an if statement inside the if statement. And lastly, we have the switch. So that ends this program. Thank you for listening.